This iconic image is a neural network, and it's the model architecture that underlies systems like ChatGPT. But how exactly does it work? I'm a computer scientist specializing in AI. Let's walk through it. See how it looks like a graph of connected neurons in the human brain? The dots are actually called neurons or nodes, and the lines between them are connections that pass information. These lines are also called the weights of the model. You might hear that companies release the weights. On the left is the input layer, where data enters, like pixels from an image or words from a sentence. These are turned into numbers the network can process. In the middle are the hidden layers. This is where the magic happens. Each neuron transforms and combines information, spotting patterns, including ones that humans might miss. Over time, these layers, which consist of neurons, learn features in the data that help the model make decisions. For example, a model distinguishing dogs from cats might learn features like pointed ears or fur texture, all represented as numbers inside these hidden layers. On the right is the output layer, which gives the prediction, like identifying the image as a cat or dog. Now back to the weights. Each line or weight, which is represented as a number, shows how strongly one neuron, the prior neuron, influences the next. During training, the model adjusts these weights, these numbers, fine-tuning the importance of each connection until it makes accurate predictions. This web of neurons and connections is a simplified view of how computers learn to think, layer by layer. Two decisions that the engineer needs to make when they're designing a neural network is how many neurons to have in each layer and how many layers to have it all. Layers with more neurons and models with more layers tend to perform better because they can capture more nuance in understanding, but training larger models involves more compute. Now let's go back to the features. Recall that all the information in the model are numbers, but with computer vision models, we can sometimes transform those numbers to see what the neurons end up representing. So we could find shapes or textures that the model is using to make its decisions. But in language models, turning those numbers into features we can understand, called model interpretability, is harder. This creates the well-known problem where AI, or rather large language models like ChatGPT, are a black box. We don't know what features it's using to make its decisions. Research into model interpretability, however, is a major focus in AI labs today. I hope this gives a helpful overview of AI models and how they work. Share this with someone you love so that they can understand AI better. And if you have any questions at all, let me know in the comments below. If you don't know me, I'm Harper. I'm a computer scientist who studied AI for the last decade. And I'm here to make AI clear and accessible to everyone and to filter the hype and provide truth, because there's a lot of hype and there's a lot of misinformation, and I want to help everyone know what's really going on.